Good evening, students. Welcome to the live session. Good evening, Shalini, Mahendra, Lalita. In this particular session, I would like to explain the major concepts of corrosion along with the multiple choice questions based upon the corrosion. So, initially moving to the corrosion. Corrosion is the process in which a metal undergoes deterioration or destruction due to its chemical reaction with the surrounding environment. So, best examples of corrosion is rusting of iron. So, the formula of rust is Fe2O3XH2O. So, this is the formula of rust, and especially it can also be represented as Fe2O3 3H2O. So, except noble metals, that means except gold and platinum, all other metals undergo corrosion. So, in order to attain stability, these metals undergo corrosion. So, during the corrosion, what happens? A metal will be converted into its corresponding metal ions. That means, in other words, corrosion can be called as oxidation process. And in other words, it is just reverse to metallurgical process. In general, the metallurgical process involves the process of extraction of the pure metal from its corresponding compound. Coming to the corrosion, it involves the conversion of the metal into corresponding metal ions. So, corrosion can be considered as reverse to metallurgical process. Generally, corrosion can be classified into two major categories, namely dry corrosion and wet corrosion. This dry corrosion is also known as chemical corrosion. So, dry corrosion can also be called as chemical corrosion, whereas wet corrosion can also be called as electrochemical corrosion. In general, dry corrosion takes place on the homogeneous or heterogeneous surface, and it is a slow process. Coming to the wet corrosion, it is a rapid process and it takes place only on the heterogeneous surface. Especially, wet corrosion takes place in the presence of moisture. Again, dry corrosion can be classified into three types, namely oxidation corrosion, corrosion by other gases, or liquid metal corrosion. Coming to the electrochemical corrosion, broadly it can be classified into two types, namely composition cell corrosion, and the second one is concentration cell corrosion. So, wet corrosion can be classified into two types. First one is composition cell corrosion and the other one is concentration cell corrosion. So, composition cell corrosion means this type of corrosion takes place due to the presence of two or more different metals. So whenever if we consider zinc connected to copper, this is the zinc metal and that is the copper metal. Here two different metals are electrically connected and exposed to moist environment. Then because due to the difference in the composition, always zinc occupies the top position in electrochemical series and hence it undergoes corrosion. So this type of corrosion arises due to the difference in the composition, and always the metal which is higher in the electrochemical series will act as anode and undergo corrosion. And this type of corrosion is called as galvanic corrosion. And it takes place whenever two or more metals are connected electrically and jointly exposed to the moist environment. Next, moving to the concentration cell corrosion. This type of corrosion takes place due to the difference in the concentration of air or oxygen. So best example is differential aeration corrosion. So moving to the differential aeration corrosion, the well oxygenated parts will act as cathode and protected from the corrosion, whereas the poor oxygenated parts will act as anode and undergo corrosion. So coming to the differential aeration corrosion, under the given conditions, the part which experiences well oxygenation will act as cathode and the part which experiences poor oxygen will act as anode, and this anode undergo corrosion. So coming to the best example of differential aeration corrosion, whenever if we consider a zinc rod which is partially immersed in sodium chloride solution, it will be the good example for differential aeration corrosion, and this portion will be well oxygenated, whereas this particular portion will receive poor oxygen, and hence this portion will act as anode and undergo corrosion. So here corrosion is mainly due to the difference in the air concentration, and hence it is good example for differential aeration corrosion. Similarly, if we consider any metallic rod, whenever a drop of water or NaCl solution is placed, so the portion below the drop will experience poor aeration and that will act as anode, and from that particular area corrosion takes place. And also we can observe this type of differential aeration corrosion in overhead tanks. So always corrosion will be more. A line just beneath the water meniscus, here the corrosion products will be observed. So in case of water tanks, the line just below the water meniscus will show a greater amount of corrosion, and this is mainly due to difference in the air concentration. That is all about the differential aeration corrosion. On the other hand, we are having one more important form of corrosion, that is called as pitting corrosion. It is difficult to identify and also it is the most dangerous form of corrosion. So whenever if we consider any metallic structure, If a small pit is observed and we are unable to identify, then corrosion takes place from that area and it is very rapid. So it is the most dangerous form of corrosion. So let me discuss about the factors influencing rate of corrosion. So there are two major factors which influence rate of corrosion. One is the nature of metal and the second one is environmental factors. Coming to the nature of the metal, it depends upon the position of metal in galvanic series. It also depends upon the nature of metal oxide film. It depends upon the relative areas of anode and cathode. It depends upon the physical state of the metal. So like that, the nature of the metal in turn depends upon the position of the metal in galvanic series. Whenever if we select metal occupying the top position, that metal undergo corrosion and hence we have to select the metal from the bottom of the galvanic series. Especially coming to the nature of the metal oxide film, if a metal forms protective and non-porous metal oxide film, then that metal will be protected from the corrosion. Coming to the relative areas of anode and cathode, always we have to avoid small anodic areas. So whenever small anodic areas are present, the rate of corrosion is very high. Coming to the physical state of the metal, especially small areas will undergo corrosion to the greater extent. So always we have to consider large metallic surfaces. Coming to the environmental factors, especially the rate of corrosion depends upon the temperature, humidity, presence of impurities, and also it depends upon the pH. If the temperature is high, the rate of corrosion is also high. If the humidity of the air is high, it also encourages more and more corrosion. So the rate of corrosion increases with the humidity. Similarly, as the impurities in the corroding environment increases, the rate of corrosion also increases. Coming to the pH. Here, if the pH is less than 7, then that environment is more corrosive. So in order to avoid corrosion, we have to maintain pH around 11. Then corrosion can be controlled. So if the pH is less than 7, that means acidic environments will promote greater corrosion. So it has been reported that 25% of iron products are wasted annually only because of the corrosion. So that's why we have to discuss in brief about the corrosion control methods. So coming to the corrosion control methods. There are several types of corrosion control methods, especially coming to the cathodic protection. Especially buried pipelines can be protected through cathodic protection, and cathodic protection may be of two types. One is sacrificial anodic protection, whereas the other one is impressed current cathodic protection. Especially in sacrificial anodic protection, the metal which is to be protected from the corrosion will be connected to the most active metal which is anodic. Especially it will be connected to the magnesium, and iron will be protected from the corrosion. Since magnesium is anodic to the iron, this magnesium undergoes corrosion in order to protect the iron from the corrosion. So especially buried pipelines, cable wires can be protected from the corrosion through sacrificial anodic protection. And the ancient method to control the corrosion is protective coatings. Coming to the protective coatings, they can be classified into three different categories. One being organic coatings, second one is inorganic coatings, and the third one is metallic coatings. Organic coatings include paint, varnish, enamels, etc. They not only provide corrosion protection but they give decorative look to the article. Coming to the inorganic coatings, they include phosphate coating and chromate coating. And the most important category is metallic coatings, and it is classified into several types. Metallic coatings can be classified into several types. One being hot dipping method, second one is metal cladding method, third one is electroplating, electroless plating, and cementation. Coming to the hot dipping method, again it can be classified into two types, namely galvanizing, second one is tinning. So galvanizing is also known as anodic coating, tinning is also known as cathodic coating. Galvanizing involves the coating of iron with zinc metal, whereas tinning involves coating of iron with tin metal. Zinc is toxic in nature, that's why food material can be stored in tin coated articles. Especially aluminium articles can be protected from the corrosion through metal cladding process, where they will use 99.5% pure aluminium. Electroplating involves the protection, especially protection of the metal with the desired method. Coming to the cementation process, here the cementation process involves the coating of articles with zinc powder. This is all about the corrosion control methods. Now, I would like to discuss the multiple choice questions based upon the corrosion. Get ready to answer multiple choice questions based upon the corrosion. Okay, moving to the first question. The process of cementation with zinc powder is known as. The process of, you try to answer each and every question as early as possible. The process of cementation with zinc powder is known as A. Shreddizing, B. Zinking, C. Metal cladding, and D. Electroplating. The process of cementation with zinc powder is known as. Charan Sai Sriram, Rama Durga, Leela Sai, very good. Sai, very good. So, the process of cementation with zinc powder is nothing but shreddizing. So, option A is the right answer. Clear? Very good, Sriram. Let us move on to the next question. Corrosion of metal is fastest in. So, in which of the following conditions the rate of corrosion is high? Option A, rainwater. B, distilled water. C, acidulated water. D, deionized water. In which of the following conditions the metal undergoes corrosion to the greater extent? You try to think logically and then answer. Ramadurga, very good. Very good, Bhavani Sai. Yes. Very good, Sriram Sahiti. Yes. Definitely, in acidic medium, the rate of corrosion is high, and hence the right option is C, that is acidulated water. Corrosion is an example of. Corrosion can be considered as the best example of. Option A, reduction. Option B, oxidation. Option C, electrolysis. And option D, chlorination. Before answering, you just think twice. Mahendra, very good. Yes, very good. Sai. Ramadurga, check your answer. Sriram, very good. Undoubtedly, corrosion is an oxidation process. So, option B is the right answer. So, through corrosion, what happens? A metal will be converted into corresponding metal ion. That means it is nothing but an oxidation process. So, option B is the right answer. Very good, Rajeshwari. Moving to the fourth question. Composition of rust is. What is the composition of rust? Charan Sai, very good. Sahiti, Vishnu, Rebecca, Bhavani, very good. So, undoubtedly, the composition of rust is Fe2O3XH2O, and hence option A is the right answer. Moving to the fifth question. Difficult to monitor and very dangerous form of corrosion is. So, you are supposed to identify which of the following corrosion is difficult to identify and also it is the very dangerous form of corrosion. A, galvanic corrosion. B, pitting corrosion. C, crevice corrosion. D, stress corrosion. Very good, Mahendra, Rebecca, Sahiti, Ramadurga. S. Pitting corrosion is highly difficult to identify and it is the most dangerous form of corrosion. Moving to the sixth question. When gold and cobalt are electrically connected, here what are the two metals connected? Gold and cobalt. Which one gets corroded? Option A cobalt, option B gold, C both, D none. Okay, Sriram. Vamsi, very good. Charan Sai, very good. Mahendra and Sahiti, at once check your options. So, here we have to check the position of these metals in electrochemical series. So, gold occupies bottom position, so it will be protected from the corrosion, whereas cobalt occupies the top position. So, the metals which occupy top position will act as anode and undergo corrosion. So, cobalt undergo corrosion. So, the right option is A. Moving to the next question. Which of the following materials are used for coating to protect from the corrosion? So, in order to protect from the corrosion, which of the following methods we can use? Option A metallic coatings, option B inorganic coatings, option C organic coatings, option D all the above. Charan Sai, very good. Vamsi, very good. Rama Durga, very nice. Vaishnavi, very good. So, we can use metallic coatings, inorganic coatings and organic coatings. So, option D, all the above is the right answer. Moving to the next question. The position of nail undergoes corrosion is. That means you have to identify which part of nail undergo corrosion. A. Head part, B. Middle part, C. Head and end parts, D. Hole. What is the right answer? Mahendra, very good. Rebecca, very good. Sahiti. Vaishnavi, yes. Undoubtedly, both head and tail parts, that means end parts, undergo corrosion. So, option C is the right answer. Which of the following metal is added to iron in the galvanization process? So, in galvanization process, which of the following metal is used to protect iron from the corrosion? I will read the options. Option A aluminium, B magnesium, C zinc and D copper. Which metal is used in galvanization? Very good, Charan Sai. Very good, Mahendra, Vaishnavi, Rama Durga, very good. Especially in the galvanization process, zinc is used to protect iron from the corrosion. The following metal undergoes corrosion easily. So you are supposed to identify which of the following metal undergo corrosion more readily. Very good, Charan Sai. Aditya, once check your answer. Mahendra, very good. Vamsi, very good. Rama Durga, very good. Rebecca, check your answer. Vaishnavi, Rajeshwari, very good. So you have to identify the position of the iron, magnesium, copper and silver in the electrochemical series. Undoubtedly, copper and silver occupies the bottom position. So especially between iron and magnesium, magnesium occupies top position and it undergoes corrosion more readily. So option B is the right answer. The food containers are generally coated internally with the metal. So food containers are generally coated with which of the following metal? Option A, tin, B, zinc, C, copper, D, lead. You have to identify the right option. Charan Sai, Vamsi, Mahendra, Vaishnavi. Very good. Aditya. So nice. So generally they are coated with tin. Option A is the right answer because tin is the inert metal. Very good, Rebecca. Next, moving to the 12th question. The method of protection of base metal from corrosion by attaching a small anode metal is known as. So, in order to protect a base metal from the corrosion, if a small anode is attached, then that method is called as. Option A, sacrificial cathode protection. B, sacrificial anodic method. C, impressed current method. D, passive method. Very good, Charan Sai, Vamsi, Rebecca, Aditya. Too good. So, this metal is sacrificing its life because that metal is acting as anode. So, option B, sacrificial anodic method is the right answer. Rusting of iron materials is catalyzed by the presence of. So, especially rusting of iron can be increased by the presence of which of the following? A, oxygen, B, magnesium, C, aluminium, D, H+. Think logically and then answer. Rusting of iron increases in the presence of oxygen, magnesium, aluminium or H+ ions. Rusting of iron material is catalyzed. Yes, Rama, Durga, Rebecca, they gave the right option. Too good. Undoubtedly, especially rusting of iron takes place under wet conditions. So, under wet conditions, the rate of corrosion is rapid. It can be catalyzed by the presence of H+ ions. So, option D is the right answer. You have to think logically. Especially rusting of iron generally takes place under wet conditions. So it can be catalyzed by the presence of H+ ions. So option D is the right answer. So during wet corrosion in neutral environment. So here you have to consider wet corrosion. There at the cathode we can consider two different situations. So at neutral environment what happens? A, hydrogen absorption takes place. B, oxygen absorption takes place. C, oxygen evolution takes place. D, hydrogen evolution takes place. Charan Sai, Vamsi, Shriram. What about the other students? Under neutral environmental conditions, what happens? Aditya, very good. Yes, undoubtedly, under neutral conditions, absorption of oxygen gas takes place, and hence option B is the right answer. Only few students gave the right answer. Stainless steel does not rust because here you must know what is the composition of stainless steel. Steel means iron plus carbon. Stainless steel means nickel and chromium will be added. So stainless steel does not rust. So stainless steel will not undergo rusting. Why? Option A, nickel present in it does not rust. Option B, iron forms a compound with chromium. Option C, chromium forms an oxide layer that protects iron from rusting. D, both chromium and nickel react with iron. What is your right option? Share your answer. I think you are not familiar with this contest. Okay. Especially stainless steel will not undergo corrosion since the chromium present in the stainless steel will form a protective oxide layer on the iron. So option C is the right answer. You try to remember this concept. Stainless steel will not undergo corrosion since the chromium present in the stainless steel will form a protective oxide layer on the iron and thus it will be protected from the corrosion. So option C is the right answer. Substances promoting the formation of protective film on a metal are called. So especially few substances, when you consider few metals like chromium, nickel, they will form a protective layer on metals. This behavior is called as. So whenever a protective film is formed on the metallic layer, that means on the metallic surface, it will not undergo corrosion. That means this metal is not active. So they are called as passivizers. So option B is the right answer. Passivizers will protect the metal from corrosion due to the formation of protective film, and hence those metals are called as passivizers. Stains of iron on clothes can be removed by. So whenever iron stains are found on the clothes, they can be simply removed by treating with which of the following chemical? A, petrol. B, oxalic acid. C, hydrogen peroxide. D, all. You think logically and then share your answer. No, Charan Sai. You think logically and then answer. Rebecca, very good. Yes, oxalic acid is used to remove iron stains from the clothes. So option B is the right answer. Few more bits to leave this session. you try to participate actively. Anti-rust paints contain, in order to protect any metal from the corrosion, anti-rust paints will be applied. So those anti-rust paints contain, you can guess without any logic, you can guess. No, no Charan Sai. Okay, option D is the right answer. They consist of cuprous oxide. So option D is the right answer. Moving to the 19th question. Metal used for the cladding of aluminium. A. 98% aluminium. B. 99.5% aluminium. C. 99% aluminium. D. 95% aluminium. So, for the cladding of aluminium, which of the following metal will be used? Very good, Rajeshwari, Rebecca, Vaishnavi. Yes, it's 99.5% aluminium. Yes, Sriram, Ramadurga, very good. One of the following factors enhance rate of corrosion. So, which of the following factors will increase the rate of corrosion? Option A, dry air. B, pure metal. C, carbon dioxide. D, passivity of metal. You carefully follow the question. One of the following factors increase the rate of corrosion. Dry air, pure metal, carbon dioxide, passivity of metal. What is the right answer? No. No one is giving the right option. Dry air means the rate of corrosion is slow. Pure metals will undergo corrosion to the lesser extent. Passivity of metal means it will not allow metal to undergo corrosion. So the presence of carbon dioxide will increase the rate of corrosion. So option C is the right answer. Very good, Ramadurga. Okay, Aditya. Moving to the next question. Pure metals undergo corrosion to the lesser extent. So that will not enhance the rate of corrosion. Carbon dioxide will increase the rate of corrosion. One of the following gas, listen to me carefully. One of the following gas in the atmosphere do not accelerate rusting of iron. So, which of the following gas will not cause corrosion? Option A, carbon dioxide. Option B, nitrogen. Option C, sulfur dioxide. And option D, nitrogen dioxide. Charan Sai, very good. Aditya, very nice. Atmosphere consists of 78% of nitrogen. It will not accelerate corrosion. So option B is the right answer. Vaishnavi, very good. The metal easily undergoes corrosion is option A, gold. B, sodium. C, iron. D, silver. Which of the following metal undergoes corrosion more readily? That means you have to identify the position of the metal in electrochemical series. Which occupies top position will undergo corrosion more readily? Very good, Charan Sai. Sodium occupies the top position among the given metals and hence undoubtedly sodium undergo corrosion. Very good, Aditya, Vaishnavi, Sriram. Moving to the next question. The area of metal under the dirt acts as. So let us suppose it is the metal. Here dust is deposited. So the area of metal under the dust will act as A. Anode, B. Cathode, C. Depends on the metal, D. Depends on the dirt. What is your answer? Everything is clear. You have to identify the right answer. Very good, Charan, Mahendra, Ramadurga. S. That area will act as anode and undergoes corrosion. S. Very good, Aditya. Sriram. Very good. Next, moving to the next question. Tinning of iron is an example of oxide coating, anode coating, plastic coating, D. Cathodic coating. Tinning of iron is an example of oxide coating, anode coating, plastic coating, cathodic coating. You have to identify the right option. Yes, very good, Ramadurga. Whenever iron is coated with tin, tin will act as cathode to the iron and hence it is good example for cathodic coating. So option D is the right answer. Only few students gave the right option. Okay, anyhow, moving to the last question. The white pigment is, pigment means it is the coloring agent of paint. So which of the following chemical gives white color? A. Zinc oxide, B. Chromium oxide, C. Iron oxide, D. Carbon black. You people are supposed to answer 25th question. Which chemical will give white color? Aditya, carbon black will give black color. Iron oxide gives yellow or red color. Chromium also gives yellow color. So it's zinc oxide that gives white color and hence option A is the right answer. You people actively participated in this live session. Thanks for participating. Have a nice day.